Okay, hi, this is Ms. McClellan. I'm going to go over AP Stats Review 4.6.1 to 4.6.4. The first problem has me trying to find the mean and standard deviation from a table. So in order to do so, based on this probability distribution, I'm going to put my information into my calculator. So I'm going to go Stat, Edit, and then in List 1, I'm going to put 0, 1, 2, 3, and in list 2, I'm going to put 0 0.04, 0 0.18, 0 0.32, 0 0.46. So I entered the table. Then I'm going to go Stat Calc, and I'm going to select one var stats. For list, I'm going to do L1, and for frequency list, where I would sometimes leave it blank, this time I'm going to select L2, which will tell my calculator that 0 happens 0.04, 4% of the time, 1 happens 18% of the time, 2 happens 32% of the time, and 3 happens 46% of the time. So I press enter, and that gives me my mean is 2.2, and my standard deviation is 0.87. The answer is D. Next problem. So you've requested all except problem number 4 as a class, so I'm just going to do all of them. Here's number 2. Number 2, a charity in San Diego plans to sell 50,000 tickets for their fundraiser, $100 a ticket from the tickets sold. One ticket will be randomly selected, and its owner will win $1 million. The expected value for the net gain for each ticket is negative $80. What's the meaning of expected value? So, in general, expected value is the same as the mean, which is just to say that if I were to run this thing many, many times, like if I were to sell many sets of 50,000 tickets at $100 a piece, and one person would be winning $1 million every time, that on average per person, the expected winnings, the average winnings, are actually a loss of $80. The ticket owners are losing an average of $80 per ticket. If you buy a ticket, you should expect that you're going to be out $80. Yeah, I guess I don't have anything else to say. So let's do number 3. A newborn baby is categorized as low birth weight if the baby weighs less than 2,500 grams. Distribution of weights for newborns is approximately normal, so I'm going to be using normal CDF probably, with a mean of 3,300 grams and a standard deviation of 375 grams. So I have an approximately normal distribution with a mean of 3,300 and a standard deviation of 375, and I want the probability that I am, let's see, which is the closest probability that a randomly selected newborn will not be low birth weight. So that's anything greater than or equal to 2,500 grams. So anything above 2,500 grams. I'm going to use normal CDF with a lower upper mean and standard deviation, with lower bound 2,500, upper bound some big number, mean 3,300, and standard deviation 375. I press enter, and I get 0.9836. That sounds about right. I mean, most babies are not born with low birth weight. Okay, number 4. The random variable A is right skewed with a mean of 2 and a standard deviation of 10. Random variable B is B equals 1 plus 3A. What are the mean and standard deviation of B? So B is going to have a mean that is impacted both by the addition component and the multiplication component. So it's going to be 1 plus the mean of A, 3 times the mean of A. And the standard deviation of B is going to just equal the 3 times the standard deviation of A, because standard deviation cares about multiplication but not addition when it comes to transforming the variables. So this is going to be equal to 1 plus 3 times 2, and that's 7. And this one's going to be 3 times 10, and that's 30. So we've got the answer is D, the mean is 7, and the standard deviation is 30. Okay, number 5. Okay, so number 5, a business person's commute from their home to work consists of walking to the bus stop, riding the bus. So we've got 3 things to look at: walking to the bus stop, riding the bus, and then taking the train. The mean and standard deviation for the distribution of time in minutes for each segment of the commute are shown in the table, and I'm trying to figure out what the total mean and standard deviation. Okay, simple. The total mean is what you want it to be. I just have to add up all of the means. So 5 plus 30 plus 40. The total standard deviation is not as obvious. One does not simply add standard deviation. You have to add the variances and take the square root. So this will be 2 squared plus 5 squared plus 6 squared. And let's see what that equals. 40 plus 30 plus 5 is 75, so it's going to be one of these answers. I throw this piece in my calculator and I get 8.06, so the answer is C. Okay, next. That was number 5. Now we're going to do number 6. Okay, the attendance clerk at a large high school is responsible for tracking the number of days each week each student is absent from school. Let X equal the number of days absent in a week of a randomly selected student. The probability distribution of X is shown below. Is it continuous or discrete? Is part A. Well, it had better be discrete because the clerk is only recording whole numbers. We're not doing portions of days. And even if we were doing portions of days, I don't think we would do like exact portions. Like this student showed up at 8:52 and 31 seconds and this many nanoseconds and this many milliseconds, etc. It's definitely discrete. It's discrete because the X values are countable. That's 0, 1, 2, 3, 4, 5. And then with the context of the problem, we could say, since the clerk, the attendance clerk, is recording whole numbers. Okay, part B. Find the probability that a randomly selected student is absent at most 2 days in a week. So that will be the probability, probability that X is less than or equal to 2. And I'm just going to add up all of the probabilities that are less than or equal to 2. So that's 0.68 plus 0.17 plus 0.10, and that equals 0.95. Part C, find the expected number of days absent. Well, expected value is the same as the mean. And since I'm asked to show my work, I am going to say the mean of x is equal to 0 times 0.68 plus 1 times 0.17 plus 2 times 0.1 plus 3 times 0.03 plus 4 times 0.01 plus 5 times 0.01, and that equals 0.55 days. And I know that that is not a possible number for it to happen. It's not possible for a student to be absent according to our chart for 0.55 days, but that's okay because the expected value is an average, actually. So now we need to find the standard deviation of x, and for that we're going to use we're going to use one of our stats. So on our calculator we go stat, edit, and we put the lists in. Then we go stat, calc, and we do one bar stats. And if you put it in your calculator right, using list 1, list 2, you should end up with the standard deviation of 0.973 days. So we have to describe this distribution. And what I notice is that I'm going to draw it to make it easier. If this looks like this. I'm just thinking about the heights for these numbers. Okay, so I noticed that SCOV, and we don't do O because it's a probability distribution. The shape is strongly right skewed. For center, the mean is 0.55 days, and for variability we have the standard deviation is 0.973 days. And so that we include context, this is to describe the distribution of, and then I'm just going to write down what X means, the number of days absent in a week for a randomly selected student, period. Okay, next. Number 7, many babies will develop irregularities in their skull shape and require a corrective helmet. When determining if a baby will need a helmet, many measurements are taken, including head circumference. For 4-month-old babies, the distribution of head circumference is roughly symmetric, with a mean of 15.65 inches and a standard deviation of 0.41 inches. The head circumference of a baby is expected to increase by 2 centimeters each month. That's a lot. Lance, a specialist in infant helmets, would like to create a new distribution predicting the head circumference in centimeters for babies that are 5 months old. To do this, he transforms the distribution using the following expression: 2.54 times head circumference plus 2. What is the shape of the transformed distribution? So, I want you to know that these transformations have no impact on shape. So, where our original distribution was, I think it said normal somewhere. Hold on. Where did it say normal? Oh, it didn't say roughly symmetric, normal, it said roughly symmetric. So the new distribution will be roughly symmetric. Since it is a transformation. With multiplication and addition. What is the mean of the transformed distribution? Well, the mean of my transformed distribution will be 2.54 multiplied by my original mean, 15.56, plus 2, which is 41.75 centimeters. And the standard deviation doesn't care about the plus 2 part, so this new standard deviation will be the original standard deviation, which was 0.41, multiplied by 2.54, and then I don't add anything to it because adding a number to every single data point does not increase the distance between the data points. And standard deviation is a measure of spread. So this equals 1.04 centimeters. Okay. Last problem. Number 8. The distribution of the cost of utility bills for the month of July for households in a certain city in Florida is approximately normal, with a mean of this and a standard deviation of that. Let J equal the cost of the July utility bills for a randomly selected household in this city. Find the probability that a randomly selected household has July utility bills costing at least $450. Well, it's a normal distribution, so we're going to say the probability that J is greater than or equal to 450 is found using normal CDF. With the lower, upper, mean, and standard deviation of, let's see, at least, so that's going to be lower, 450, some big number for your upper bound. A mean of 469, standard deviation at 58. You put it in your calculator, you press the buttons, and you get your answer, and it's 0.6284. Next problem. Part B. Now we see why it can be made to be interesting. Suppose I'm interested in combining the total cost for July and August. What can I do? Okay, well, the August distribution is also probably normal. Yes, approximately normal. And it has a different mean and a new standard deviation. Well, I can combine these random variables and find the new mean and standard deviation. So let's do that. The mean of J plus A is equal to the mean of J plus the mean of A, which is 450 plus 498 equals 967. And the standard deviation of J plus A equals the square root of, I have to add the variances, 58 squared plus 73 squared, and that is equal to 93.24. Now, usually after you find a mean and a new standard deviation, if you're doing a free response question, you will be asked to use normal CDF. or some other distribution's cumulative function. So for part C, we're doing find the probability of randomly selecting a household in the city with a combined utility cost for the months of July and August that is less than $800. Less. So it's going to be normal, CDF, lower upper, mean standard deviation. I'm talking about everything less than 800, so that's going to be the upper bound. Lower bound, some ridiculously small number. Could you make it 0? Sure. Do you have to? No. Mean 967, standard deviation 93 and 24 cents. And we get an answer. It's 0.0366. I think that's the last problem. It is. So we're done. Thanks so much for your time, and I hope you have a very nice rest of your day. Bye.